Hi, in this video on my Arduino Mega2560 with a brand new breadboard, more space, I want to focus on the motor. Last time I added this motor using a transistor, a resistor, to the LEDs. With the spot meter I can adjust the voltage, and with that I can adjust the speed of the motor, to which I have added a fan to make it more clear that it actually runs. However, as it turns out, I have to start with quite a lot of voltage to get it running, while less voltage is needed to keep it running. So I turn it around quite a bit, and then suddenly it runs. And when I turn it back, you can see that it keeps running at quite a low speed. Like this speed I only have when I turn it back, not when I turn it on. So now I have to adjust the speed. So I want to see if I can change the code that it also starts at quite a low speed. So let's see how and if we can do that. So coming back to the code with the 3 LEDs and the motor output, I wonder if adding half or 2 is of influence on the lowest, on a low starting point of the fan turning around. So I'll start with half, and then keeping everything the same. And is there anything else I should change? Not really. So starting at half, and then I will increase with half to see if anything, or with a tenth, I think that's better. We'll see. Anyway, let's upload. Done uploading. So let's see how that works out. So I've changed the code and reduced the output value by 2. Let's see how this works out. And actually it doesn't work at all, because now it doesn't want to start. So I have to do it the other way around. I have to multiply by something bigger than 1. Let's try, and I have to keep an eye out for these voltage. So okay, that's not a good plan to multiply with half. That was a clear show that the motor doesn't turn at all now, which means a half isn't good. With 1 it can go. It shows that it does turn, but quite late. So what happens if I replace it by 1.5? Considering the fact that with a half it doesn't start at all or hardly, 1 it starts late. Yeah, this might be it. So with the multiplication factor changed to 1.5, let's see how this works out. And that's quite an improvement. It very slowly and then sudden start. Like a very slow start, and then it begins turning it back. Slowly, slowly, slowly. Slower. And very slowly till it stops. So now it runs very slowly. And let's increase it by 1.5. Let's see what happens then. So increase by 1.5 to 2. And you see that although it doesn't run slowly at start, it starts a lot sooner. So the question is, can it turn slowly after all at start? And the way I see this, it only starts to run earlier at a faster pace, but that I cannot let it start running slow, and that is too bad. So let's see what more we can change to the circuit. As the last part, I've added an NTC resistor. NTC is negative temperature coefficient, which means that with an increased temperature the value of the resistor falls, and vice versa, of course. And since this is an input instead of an output, I've connected it by jump wire to analog input 7 in this case. So let's see how this adds to the code. Since the NTC is an input, I will put the input here, const and analog in pin is, and I put it to A7, analog input for NTC. Then int sensor value is 0, read from NTC, let's add it here, so okay. And then I have to read from it, so and here I have to of course to change things, because analog pin 7 is when I keep these two the same it will go wrong, so analog in pin 7. Then I have to read in the value, and I guess I will do that here. Sensor value, which I have to change here as well, 7. Seven is analog read analog in pin 7. Let's see, is everything still okay? Looks like it. And let's see how I can do that. Serial print, not here, print line, but print tab, not output 4 but input NTC is and then serial print, and here we have sensor value 7, and here we do have a print line. So who knows, this is going to work. Let's just see it. Done uploading. Starting the serial monitor. Right now it says 0. So let's just start the whole thing. And you can see that the resistor value is not really constant, but it gives some let's see if we can see a pattern. Now it's not the fan is not running, and now it is. Now it stopped. Anyway, I have to dive into this more, but it gives some nice values, and I think this concludes the experiment for now. So thank you for watching, and to be continued.